that's where we're going to start. So go ahead, it's been activated, go ahead and you started to answer it the last time. And commit to an answer. Okay, I'm going to cut off voting in 5, 4, 3, 2, 1. More than half of you are wrong, so I want you to discuss it with several people around you. Again, if the person next to you has the same answer, turn around or move to another part. Really try to find someone with a different answer and discuss the logic behind your answer, and then we'll revote. So go ahead.
Couldn't read about the A's right answer because it's just pitching. It's not going to be moving into that. A's wrong because we're not thinking about this. The receptor will still be able to bind LDL, but it would just do the without it, it won't be able to change this intent. So it's not going to be that. So we just keep putting now LDL, it needs tyrosine. The membrane needs tyrosine and that lysosomal plasma center.
So that's the part of the
And we talked about what tyrosine is used for in the LDL receptor. So that's a critical sentence in that question.
I said D. Basically, shake up on the other sectors and bring it again. So parasitic air, those are trying to keep being put on the plasma membrane, but there's no signal off the plasma normally done there chapters to be endocytosis. So the come back in, you got because there's no signal of tyrosine, they just keep being put on the plasma membrane. It's not going to take it back in. Exactly.
Excellent. Okay, I'm going to cut off voting in 5, 4, 3, 2, 1, and this was great. This is an Insta poll that worked really well. we had, people were choosing A, B, C, and then half of you were various things. And we saw a dramatic shift to D right here, which is the correct answer. The LDL receptor would be concentrated on the plasma membrane. So can someone who chose that answer explain their reasoning, maybe with using this? Maybe someone who shifted their answer, who saw the light. Go ahead.
So when I first read the question, I kind of forgot about the word protein.
Uh-huh.
So I assumed that the amino acid was part of like the binding area towards LDL, so I chose A. But then after your hint and reading like the second slide, I realized like tyrosine was important for the association of like the vesicle function. And so without that, then there would be no budding, and so the receptor would stay on the plasma.
Okay, that is does anybody want to modify that answer? A lot of that's correct, but I want to modify a little bit. Anybody see, and you may not have been able to hear also, so let me just modify that. So the tyrosine has nothing to do with the budding of the coat formation of Clathrin-coated pits. Those happen spontaneously. As we've seen with other coats, actually this one's different and there's not a small g, but coat formation is controlled generally by GEFs and small G proteins that control where coats run. This one's an exception, but those form spontaneously. So those have nothing to do with the LDL receptor. And let's also remember that there are many receptors on the plasma membrane of this liver cell. This just shows the liver cell, but we have EGF receptors, insulin receptors, many receptors that might be going in through Clathrin-coated pits. So, but what you were correct was we removed the signal on that tail. So without that signal, so the Clathrin coats would still form, but there's no longer a signal for these to concentrate within the Clathrin-coated pit. So here we have right here the situation where this, this adaptin is meant to be AP2, as you know, AP2. And AP2 recognizes that tyrosine on the receptor tail, and without that, these would still bind to LDL, but they would no longer have the signal to be recruited into the Clathrin-coated pits, and so they would concentrate on the plasma membrane. Okay. And I had a good question in the back that I want to clarify. Someone asked, what would happen, does the binding of the LDL receptor expose this tyrosine so that it can go into Clathrin-coated pits? And the way this particular receptor works, that is not the case. If we removed LDL completely from the blood in this liver cell, this receptor would still recycle just empty. So it's just always going in a circle. It turns out other receptors are not like that. Other receptors that use Clathrin-coated pits, so the insulin receptor is an example of one that when it binds insulin, that causes a conformational change in the tail that'll expose the signal for concentrating in Clathrin-coated pits. So it depends on the particular receptor, and we don't really expect you to know that. Again, the way this works, just to review, is it will bind LDL and it goes in, and then the early endosome is a sorting compartment where the LDL releases the receptor releases LDL. The LDL goes on to lysosomes where it's degraded, and the receptor goes up empty to pick up more LDL receptor. And once more, this was discovered by genetic studies at the Brown and Goldstein lab, who identified, the tyrosine signal was identified, who identified through studying families that had very high cholesterol, discovered one family that had a mutation in the LDL receptor. And that one mutation was that tyrosine that was changed. So without it, LDL levels really accumulated in the serum because although the receptor could bind to LDL, saturate the receptors on the plasma membrane, and there's no way to internalize it. You run out of it. And people who were homozygous, that family that was homozygous for that had extremely high levels of LDL and died in their 20s of heart attacks. Heterozygotes who had one good receptor that was doing the best it could died more like age 50. And I want to say one more thing, which is that familial hypercholesterolemia is pretty common. It could run in some of your families, but this mutation is extremely rare. So if your family tends to have high cholesterol, don't worry that you have a tyrosine mutation in your LDL and you're doomed in the next 2 years or something like that. Okay, so that's finishing up, and now we're going to move on to nuclear transport with Dr. DeLozan. But first, any questions? Okay.
It often happens that after you learn something and then you take the exam, then you allow your brain to forget about it, right? So don't forget about any of this, because we are going to come back to talking about cholesterol, such an important thing. The very, very last class in the semester, we're going to talk about regulation of levels of cholesterol in the body, different mechanisms, and even more in detail regulation of the LDL receptor itself, for how much should it be presented, how much should it work. So keep all of this in mind, don't forget about it for the rest of the semester or the rest of your lives. All right, so let's move on to